Hello friends, I am Rutuja Mankar, student of Sri Chandragajanan Maharaj College of Engineering, Shillong. Today we will learn about the hierarchical file system. In that we will see a brief introduction, history, design and the limitations of hierarchical file system. So let's start with the introduction. Hierarchical file system is a proprietary file system developed by Apple Incorporation for use in computer systems running Mac OS. Originally designed for use on floppy and hard disk, it can also be found on read-only media such as CD-ROM. HFS is also referred to as a Mac OS standard, while its successor HFS Plus is also called Mac OS Extended. With the introduction of OS 10.6, Apple dropped support to format or write HFS disk and images which are only supported as read-only volume. History. HFS was introduced by Apple in September 1985, specifically to support Apple's first hard disk drive for the Macintosh, replacing the Macintosh file system. The original file system, which has been introduced over a year and a half earlier with the first Macintosh computer. HFS draws heavily upon Apple's first hierarchical SOS operating system for failed Apple III and Apple Lisa. HFS was introduced by Patrick Deer and Bill Bruffett. It shared a number of design features with MFS that were not available in other file systems of the time. File should have multiple forks which allowed the main data of the file to be stored separately from the resources such as icons that might need to be localized. Files were referenced with unique file IDs rather than file names, and file names would be of 255 characters long. However, MFS has been optimized to be used on very small and slow media, namely floppy disk. So HFS was introduced to overcome some of the performance problems that arise with the introduction of larger media, notably hard drives. Let us see the design of a storage volume is inherently divided into logical blocks of 512 bytes. The HFS groups these logical blocks into allocation blocks, which can contain one or more logical blocks depending on the total size of the volume. HFS uses a 16-bit volume to address allocation block, limiting the number of allocation blocks to 65535. Five structures make up an HFS volume. Logical blocks 0 and 1 of the volume are the boot block, which contain system startup information. For example, the name of the system and shell files which are loaded at startup. Logical block 2 contains the master directory block. This defines a wide variety of data about the volume itself. For example, date and time track for when the volume was created, the location of the other volume structures such as the volume bitmap or the size of the logical structure such as a location block. There is also a duplication of the master directory block called alternate master directory block located at the opposite end of the volume in the second to last logical block. This is intended mainly for use by disk utilities and is only updated when either the catalog file or extends workflow file grow in size. Logical block 3 is starting block of the volume bitmap, which keeps a track of which allocation block are in use and which are free. Each allocation block on the volume is represented by a bit in the map. If it is clear, then the block is free to be used, since the volume bitmap must have a bit to represent each allocation block. Its size is determined by the size of the volume itself. The external overflow File is a B tree that contains extra extent that records which allocation block are allocated to which file. Once the initial tree extents in a catalog file are used up, latest version also add the ability for the extend overflow file to store extent that record bad block to prevent system from allocating a bad block to a file. The catalog file, another tree that contains record for all the files and the directories stored in volume. It stores four types of record. Each file consists of a file, thread record, and the file record, while each directory consists of the directory thread record and the directory record. Files and directories in the catalog file are located by their unique catalog node ID, that is CNID. A file record stores just the name of the file and the CNID of its parent directory. A file record stores variety of metadata about the file including its CNID, the size of the file, three timestamp, the first file extension of the data and resource book, and pointer to the file's first data and resource extent record in the extent overflow file. The file record also stores two 16-byte fields that are used by the finder to store attributes about creator code, type code, the window of the file should appear in and its location in a window. A directory thread record stores just the name of the directory and the CNID of its parent directory. A directory record which stores the data like the number of files stored within the directory, the CNID of the directory three times. Like the file record, the directory record also stores two 16-byte fields for used by the finder. This stores things like the width and the height and x and y coordinates of the window used to display the content of the directory, the display code of the window, and the position of the window scroll bar. Now, here are some limitations of the hierarchical file system. The catalog file which stored all the file and directory record in a single data structure results in performance problem when system allows multitasking as only one program can write to this file at a time, meaning that many programs may be waiting in queue due to one program hogging the system. It is also a serious reliability concern as damage to this file can destroy the entire file system. This contrasts with the other file system which stores the files and folder in other separate structure where having the structure distributed access the disk means that damaging a single directory is generally non-fatal and data may possibly reconstructed from the data held in the non-damaged portion. Additionally, the limit of 65535 allocation blocks resulted in files having a minimum size equivalent 1 by 65535 the size of the disk. Thus, any given volume, no matter its size, could only store a maximum of 65535 files. Moreover, any file would be allocated more space than it actually needed, up to the allocation block size. When disks were small, this was of little consequence because the individual allocation block size was trivial. But as this started to approach the 1 GB mark, the smallest amount of space that any file could occupy became excessively large, wasting a significant amount of disk space. For example, block size under HFS is 16 KB, so even a 1 byte file could take up 16 KB of disk space. This situation was less of a problem for user having large file because These larger files wasted less space as the percentage of their file size. User with many small files, on the other hand, could use a copious amount of space due to larger allocation block size. This made a partitioning the disk into smaller logical volumes very appealing for Mac user because small documents stored on the smaller volume could take up much less space than if they reside on a larger partition. Existed in the FAT16 file system. This saves the case of a file that is created or renamed but in case sensitive in operation. Here are some now here are some questions related to this topic. Let's have a look. So this is all about our topic. Thank you so much for watching this video.